Solve the system of equations using substitution. This video is going to show you how to solve the system of equations algebraically using substitution. Now remember, system of equations means you're basically taking this linear function here and this linear function here, not graphing them, but finding where they intersect on the coordinate grid. So you're going to have a coordinate for x and you're going to have a coordinate for y. So the first thing that you do using substitution, you try to substitute somewhere with the two equations. Since this is equal to y and this is equal to y, they're both equal to y, I'm going to circle the 10x plus 20 and I'm going to substitute it in for y in the other equation. Alright, since 10x plus 20 is y, I'm going to substitute that in. So I'm going to rewrite the equation 10x plus 20, because that is y right now, that's y, equals 20x plus 10. What you have is an equation with variables on both sides, and it's the same variable now. So you subtract the 10x from both sides, bringing the smaller over to the larger. Use inverse operations to do that. They cancel over here because that equals 0. Bring down the 20, the equal sign. 20x minus 10x is 10x. And you bring down the plus 10. This amounts to a two-step equation. Again, you're passing the equal sign, so you use inverse operations again. You cancel that out. 10x comes down, equals 10. You divide by 10 on both sides. 10 divided by 10 over here cancels out, and 10 goes into 10 once, so x is equal to 1. So x is equal to 1 right there. So you have one of your answers. You need a y. What you have is one part of where they cross or intersect, but you need a y coordinate. So I'm going to put this 1, this is x is equal to 1, into one of these, substitute into one of these equations. Doesn't matter which one you use. So I'm going to use the first one, y equals 10x plus 20. So y, you don't know what y is. 10 times x, which is 1, in this case, because that's what you solved, that x is equal to 1. So you put that right here, and then plus 20. 10 times 1 is 10, plus 20. That is y equals. And y equals 30. So the system of equations of these equations crosses at 130. You could check by substituting this x and this y into each equation and see if it works out. So this is y and here's x. 130. And that's how you solve using the system algebraically using substitution. Going to the next page, just wanted to show you this one because it's a little bit different. All right, one equation's equal to y, but the other is not. And if you take a look at what we did in this page, over here, where both were equal to y, we set them equal to each other because they're both equal to y. Well, this one is not equal to y in both equations. This one is a little bit different. So you have y equals 3x plus 8, and you have 8x plus 4y equals 12. So the 3x plus 8 I'm going to circle because that's the one that's equal to y. And I am going to substitute this 3x plus 8 right there. I'm going to put this 3x plus 8 in for y because that is y. They're telling me y equals that. So that's what I'm putting right there. So when I rewrite this equation, you have 8x plus, and instead of y, you're going to put 3x plus 8. You are substituting the 3x plus 8 for y, and that equals 12. So you have some work to do here. It's distributive property. Anytime you see the parentheses, basically going to distribute. So before I do that, I'm going to bring down the 8x and the plus sign, and do 4 times 3x is 12x. 4 times 8, don't forget about that. That is 32. And you have equals to 12. So I'm going to bring that down. When you have the variables on one side, you're combining like terms. 8x plus 12x is 20x. Bring down the plus 32. Bring down the 12. You subtract 32 from both sides. This is a two-step equation. Use inverse operations to start to get the x alone. So you have 20x equals negative 20. You divide by 20 on both sides. And again, for the second straight problem, the 20s cancel out, and x equals negative 1 this time. Again, you need a y, because what you have is half of the system. All right, you have your half coordinate. You have the x coordinate, but not the y. You need the y. This first equation is y equals 3x plus 8. This x goes in to here. So I'm going to rewrite that equation. You're picking that equation, by the way, because it's already solved for y. So you wouldn't pick the second equation because that's not solved for y. But you can use this second equation, but then you're really asking for more work because you have to solve it for y at the end. If the equation is solved for y already, obviously you're going to use it. So for the x, you're putting in negative 1 because that's your answer. So you have y equals negative 3, because 3 times negative 1 is negative 3, plus 8 y equals and it's a positive 5. So the system of equations using substitution is 1, 5. And that's how you solve the system of equations using substitution. One more equation I would like to do is a little bit tricky. You notice that the problems that we did before, One of the equations was solved for y, which makes the substitution easy. And if we're going to find the system of equations using substitution, we're going to have to actually solve one of these for y. There's a couple of ways you can do this, but I'm going to just go ahead and rewrite y plus 3, because you need to have something equal that y equals to use that substitution. So you have y plus 3 equals 2x. I'm going to write that first one down. It's very easy to solve this for y. You go ahead and look at the side where the y is, and you subtract 3 from each side. Subtracting 3 will leave y alone, and you see that you have y equals 2x minus 3 now. And you have y equal to 2x minus 3. So now you could take this 2x minus 3, all right, I'm going to circle it, 2x minus 3, and I'm going to substitute it right here for this y. Because I solved for y, y is 2x minus 3. I'm going to put that in for here. And this is substitution. So when I rewrite this equation, it's going to be x plus, instead of y, I'm going to put this, 2x minus 3. And all of that equals 18, because I'm following the equation, the second equation, this one. So x plus 2x, since they're on the same side, is 3x. Bring down the minus 3. Bring down the 18. Remember, this is substitution. You're adding 3 on both sides, and you get 3x is equal to 21. Divide by 3, again, getting the x alone, and x equals 7. But again, we do not have a y. So what we have is just the x-coordinate of where those lines, those linear functions cross or intersect. So I'm going to use that. I solved for y here. So that's what I'm going to use. Y equals 2x minus 3. And y equals 2 times, and instead of x, I'm going to put 7, because that's what I solved for, and that's what I think the x is. So 14 minus 3 and y equals 11. So my coordinate that these lines intersect, the system is 7, 11. And that's how you would solve using substitution.